Okay, students, at this point, we're going to practice performing some operations on complex numbers, adding, subtracting, and multiplying. Now, when I'm asked to add or subtract two complex numbers, the key is to treat them like you would treat like terms in a polynomial addition problem. I'm going to add or subtract like parts, meaning the real part plus the real part and imaginary plus imaginary. Pretty simple. Here I've got 5 is a real part, 7 is a real part. Add them together, makes 12. 4i for an imaginary part, 2i for an imaginary part. Add them together, I get 6i. 12 plus 6i is my answer. It's pretty simple stuff. Next, subtraction. I always got to be careful when subtracting. I like to think of it as I'm distributing the negative sign, so negative times negative is positive, so really we're going to add 3. And negative times negative again, really we're going to be adding the I. Now the other imaginary number I can just leave as 6 minus 7i, just without the parentheses. So at this point then, I'm going to combine like parts. 6 plus 3 is 9. Negative 7i plus 1i is going to be negative 6i. So 9 minus 6i. There's your answer. Now with multiplication, multiplication of complex numbers is similar to distribution or the FOIL method. Now the thing that I have to be careful with is with I squared. If that were ever to show up in my answer, that would be incorrect because I squared has a value. I squared is equal to negative 1. Reason behind that would be this. I is defined as the square root of negative 1. So if I were to square both sides of that equation, I would end up with I squared, and on the other right side, the square root of negative 1 squared is going to be just negative 1. So a little explanation for you. You will not see I squared in an answer. You will see a negative 1 in its place. Using that idea, let's work on this first one. We're going to distribute negative 2i to both terms in the other complex number. Negative 2i times 3 is going to be negative 6i. And then negative 2i times negative 5i is going to be positive 10i squared. But remember, I squared is equal to negative 1. So I'm going to replace I squared with a negative 1 and think about what that will do to my answer. So instead of 10 times I squared, we'll take 10 times negative 1. Well, that's going to be negative 10. Now, I write it first, and then I write the imaginary part, negative 10 minus 6i, because I'm told to put it in standard form. Standard form always has the real part plus the imaginary part. So real plus imaginary, standard form, ready to go. With the second problem, I've got 2 parts to each, so we're going to have to use FOIL here. First term times first term. 5 times negative 4 is negative 20. Outer terms multiply together become negative 15i. Inner terms multiply together, we're going to have negative times negative, so it's going to be positive 28i. And finally, last terms, negative 7 times negative 3 is positive 21. I times I is I squared. And once again, remembering that this I squared is going to really be a negative 1. So putting some things together, this is going to turn into negative 21. Negative 21 and negative 20 go together to become negative 41. Imaginary parts go together. Negative 15 plus 28 is going to be positive 13i. So negative 41 plus 13i, standard form, finished answer. Now, the cool thing about complex numbers is that as simple as this was, if you struggled to add, subtract, or multiply complex numbers, you could get away with using your calculator to do the same things. For example, if I want to do this first problem where it was 5 plus 4i plus 7 plus 2i, I can type that into my calculator. Here's how. Parentheses, 5 plus 4i. The I is right above the decimal point. So I hit second and then the decimal point. This is not showing up. It's not going to work for me if we do it this way. All right, never mind. We'll show you that another time.